here's two other blocks. You can see that they're very different in terms of how they look. Very dark, and this one's a bright green. You can also see this has many veins cutting through it. This one also has veins. They're a little bit more difficult to see. It's these veins that tell us that these rocks have gone down into a subduction zone, at least far enough for the pressures there to start to split the rocks up. That's why we know these are not landslides from a continental margin down into the deep ocean. They actually had to have gone down into the subduction zone. The interesting thing is, here these two blocks are sitting right next to one another, and they're very different in composition. Also know how rounded they are. This rounding comes from being reworked in the subduction channel. They're rolling around like this in the subduction channel, and the shear is also knocking off some of the blocks into smaller pieces and knocking off their edges and making them more round. So this is a piece of the Earth's mantle right here. This piece is what we call a blue schist, meaning that this was made up of sandstone that was subducted and went so far into the subduction zone that it recrystallized. The minerals that make up this rock can only crystallize at depths of 30 to 40 to 50 kilometers. And then, after it went down that far, it was forced back up through the subduction zone because so much more material was coming down. It's forced it back up here on the surface, and on its way up, it mingled with this rock right here, which was plucked off of the upper plate. So this stuff's coming up and plucks this rock off the upper plate, and now they're sitting here together in the melange. So this is how a subduction channel works.